I'm Jay Groves. I'm a professor of chemistry here at Princeton. What we set out to do was to discover a catalyst that could put fluorine into important drug molecules in ways that had not been done before. Fluorinated drugs are important because they're more potent. Fluorinated drugs also can be used to image the brain, but there was no good way to put fluorine into these complicated drug molecules in a single step. We discovered a catalyst that contains manganese wrapped in a particular support molecule, which is the very same one that you find in blood. It's the reason our blood is red. This is heme. So what we did was to take the iron out of heme and put in manganese, and learned how to make that molecule a catalyst. And we discovered a process to use this catalyst in simple fluoride ion salts. And therefore we could avoid using fluorine gas, which is dangerous. There are many accidents. You have to be highly specialized. The equipment is expensive. And we got around all of that. Fluorinated compounds are metabolized more slowly. Now what this means is that the dose can be lower because it lasts longer. There are really two flavors of fluorine. There's the stable isotope. This is called fluorine-19. And if we want to have a long-lasting drug, a longer-lasting painkiller, a molecule that could be given in lower doses, we would put this fluorine-19 in the molecule. But there's another kind of fluorine, which is radioactive. It's called fluorine-18. And our method, it turns out, is also excellent at putting this radioactive version of fluorine that lives only 2 hours. When this fluorine-18 decomposes, it gives off positrons. And you may have heard about positron emission tomography. This is a way to image the inside of the body. So we can actually put fluorine-18 into drug molecules and see exactly where they go. For example, we could target a tumor in the brain, or we might be able to target inflammation in the brain. That's an early sign of Alzheimer's. This is a disease that affects more and more people as people live longer. Part of the problem in designing or discovering and developing a drug is that we really can't see where it is in the patient. Does it even get to the area in the brain that is affected? So PET scanning is a way to do that. The prospect of being able to put an F18 label on an Alzheimer's drug is at least the workers will know where the molecule is, how much of it is there, and did it bind and find the right place. One of the good things about catalysis is that if we change the catalyst, we can change the places that we put these molecules or atoms. So we can put fluorine or chlorine or nitrogen almost any place in a molecule that we would like. So these will have high impact on society, and it's very satisfying to know that.